So as I said, there's a local minimum at x is equal to 15. Okay, so now using x is equal to 5, we're going to sub that into the second derivative. So we get minus 240 plus 24 multiplied by 5. So we just swap the x for a 5. 24 by 5 is 120. Minus 240 plus 120 is minus 120. And minus 120, we know, is less than 0. So therefore, there's a local maximum at x is equal to 5. So there was a local minimum at x is equal to 15. And we have a local maximum at x is equal to 5, because minus 120 is less than 0, which gives us a local maximum. And this is at x is equal to 5. So now I want to figure out what the required dimensions are for the maximum volume. So I'm going to use x is equal to 5. So the length, the formula for the length that we worked out was going to be 30 minus 2x. So we're going to swap the x for 5 because we got x is equal to 5. So 30 minus 2 times 5 is going to be 30 minus 10, which is going to be 20 centimeters. So our length is going to be 20 centimeters. We do the same for the width. 30 minus 2 times 5 is also 20 centimeters. And then the height we know was just x, so we just get 5 centimeters. So this is a sketch of our 3D shape. Remember that the length was 30 minus 2x, so that's where we got 30 minus 2 times 5 from. We swapped the x for 5, and we got 20. The width was also 30 minus 2x, so 30 minus 2 times 5, again we got 20. And the height was x, so we just sub in 5 straight away, we get a height of 5. It's important to note that we don't need to bother to sub in x is equal to 15. Although I know we found x is equal to 15, but that was telling us where the local minimum was. But we are only interested in this question in the maximum dimensions and the maximum volume. So since we found the local maximum to be at x is equal to 5, we only need to sub in the 5 in place of the x for each of these formulas. So part 2 says, what is the maximum volume of the box? Well, we got our maximum length to be 20, maximum width to be 20, and maximum height to be 5. So the maximum volume of this box would be 20 by 20 by 5, which is length by width by height, which gives us 2,000 centimeters cubed because we're dealing with volume. Alternatively, we could have gone back to our volume formula, which was 900x minus 120x squared plus 4x cubed, and substituted 5 in place of each of the x values. So our maximum volume is 900 multiplied by 5 minus 120 times 5 squared plus 4 times 5 cubed will also give us 2,000 centimeters cubed.